Hey everyone, it's Mr. Rosenberg, and for this video we're going to be looking at Chapter 6, Section 3, which is binomial radical expressions. And the objective here is to add and subtract radical expressions. So first let's talk about like radicals. So when we're dealing with like radicals, it's very similar to dealing with like terms whenever we're trying to simplify an expression. So like radicals are radical expressions that have the same index and the same radicand, right? And if you don't remember, if we take a look here, we have our index, which is this value of n right here, and our radicand, which is the number that's under our radical. So here's some quick examples, right? We have like radicals with strictly numbers, right? So this first example, we have the square root of 2 plus 3 times the square root of 2, right? These are like radicals because they're both the square root of 2, so they have the same index and the same radicand. And when we add them together, we're doing 3 plus 1, that gives us 4 root 2. And it's the same thing for the second example. Here we're dealing with cube roots. We have the cube root of 7 minus 5 times the cube root of 7. Right? Both have the same index and the same radicand, so we're able to combine them. Right? And this is basically 1 times the cube root of 7 minus 5 times the cube root of 7. That just gives us negative 4 times the cube root of 7. And it's the same way for like radicals when we have variables as well. All right, so square root of 5xy plus 8 times the square root of 5xy. Well, that's just 9 times the square root of 5xy. And here we have the cube root of 9x squared y minus 8 times the cube root of 9x squared y. Well, that just gives us negative 7 times the cube root of 9x squared y. And here's just the last page kind of summed up into a couple of rules. So if we have a times some root x plus b times that same root x, well, we can just add the two coefficients together and leave the index, radical, and radicand the same. And the same goes for subtraction, right? We can just subtract those coefficients.